Okay, we are looking at lesson 17-3, area of parallelograms and triangles, today on page 434. Alright, so let's look at this. It says, how can you use the formula for the area of a rectangle to find the area of a parallelogram? So actually look at this parallelogram below and notice that if you move the triangle to the opposite side, you actually form a rectangle that's of course going to have the same area as the parallelogram. So a parallelogram looks like a rectangle that's just been kicked over to its side a little bit. And what they're saying is if I take one of these triangles off the side, like this piece right here, and I take it and I move it over here, like they're showing, what you actually have is a rectangle. So it will have exactly the same area if I moved it and made a rectangle or kept it a parallelogram. Let's look at the next page. Okay, so on page 435, on the left side I have the parallelogram right here. Okay. On the right side I have this parallelogram with that piece moved over. So it's the same figure, just with this rectangle cut off and moved over to the right here. Okay, they've got this rectangle moved over there. So, but I'm going to go ahead and erase it. And what they're trying to show you here is that the base of a parallelogram actually equals the length of a rectangle. So from here to here, it's the exact same distance as if I take that piece and I moved it over here, the length from one end to the other. And the height of the parallelogram, okay, right here, is equal to the width of the rectangle, right here, from here to here. So let's look over to the right. That's why the area of the parallelogram equals the area of the rectangle. So here's our area of the rectangle. Area is length times width. Here's my area of the parallelogram. Area is base times height. Okay, let's look back on to page 434 again. Alright, so how can you use the formula for the area of a parallelogram to find the area of a triangle? We've talked about this with a rectangle before. Since two congruent triangles can form a parallelogram like they show here below, the area of one triangle must be half the area of a parallelogram that has the same base and height. Or, let's look at it backwards. If I have a parallelogram like they do right here, and I drew a line from one end to the opposite end, corner, vertice, I would have cut it in half and I would have two triangles. So, and if I look at the picture over here, I have one base, which is going to, because this side is equal to this side, which is equal to the other base. And in a parallelogram, my opposite sides are congruent. Okay, so I have congruent triangles, and what I have done is I've taken, here's the area of a parallelogram. Area is base times height for this whole piece, for the whole parallelogram. When I cut it in half to make my triangle, well, then the area of a triangle is of course going to be half of the base times the height, which is where we get the formula. Okay, if you look at explain it, it says a rectangle and a parallelogram have the same base and height. How are their areas related? Well, just like in the picture on the top of page 435, they had the parallelogram, move the piece over to make a rectangle. They're going to have the same area, or their areas are going to be the same. Number 2 says a parallelogram and a triangle have the same base and height. How are their areas related? Well, just like in the picture above, the triangle's area is going to be half of the parallelogram's area. Let's look back over to more examples on the next page. Alright, on page 435 they give you some other examples here. So here they say find the area of the parallelogram. Well, always write your formula first. Area is base times height on a parallelogram, and then plug in your numbers. Here's my base, 10. Here's this dotted line with the right angle is always my height, 3. So 10 times 3 is 30. Always have your units in there, so we're multiplying inches times inches here, so the area of the parallelogram is 30 inches squared. And then it gives you another example of finding the area of a triangle. Write your formula. Area of a triangle is 1/2 of the base times the height. Here's my base of my triangle, so they plug that in at 15. And then here's the height. You always find that line with the right angle there, which is 8. Multiply these together. 15 times 8 would give you 120, and then multiply by 1/2, which makes you divide by 2. So that would give you the area is 60 centimeters times centimeters, so 60 centimeters squared. Alright, look at the guided practice. I'd like you to go ahead and do all of it. 1, 2, 3, and 4, you're finding the area. 5, 6, and 7, you might want to draw a picture to help you explain this question. Number 6, it looks like you're working backwards. You're finding the height instead of the area. So use your area formula for the triangle and then solve to find h. And then writing to explain number 7. So bring this all to class with you tomorrow along with the question, and I will see you then.